Hey guys, we are doing our first solving logarithmic equations, chapter 8.4. So we're going to take it step by step, really easy. The first thing that I need you to realize is that a logarithmic equation is simply an equation where you're solving for x, and it has a log in it. That's all it is, okay? These first couple examples are just like what we did in chapter 8.3, okay? Where the only way that we know how to work these problems is if we have put it in exponential form, which means that 36 is my base, 3 over 2 is my exponent, equals x, okay? So copy the problem down. Give you a second. Then put it in exponential form. So 36 is my base, 3 over 2 is my exponent, x is my answer. Now, remember, this 2, the denominator, means the square root. So I asked myself, what is the square root of 36? And the answer is 6. So I have 6 cubed equals x, because I took the square root of 36 and then I cube it. Now, what is 6 cubed? 6 cubed is 216. There's my answer. Okay, now let's say that I didn't know that 36, the square root of 36 is 6. So you could come over here and I can change 36 to a base of 6. And I have 3 over 2. My 2's cancel, leaving me 6 cubed. Okay, but I think right now it'd just be easier if you know what square root of 36 is. All right, second equation. Log a base 9 of x equals 3 over 2. What's my base? It's 9. What's my exponent? 3 over 2 equals x. Okay, what is the square root of 9? It is 3. Lord help me. And then I have 3 cubed, which equals x. Don't ask me why I put parentheses around there. I just did. So x equals 27. There's my answer. Okay, so that is one type of an equation that we can work with logarithms. Okay, another type of an equation is where, if you notice, we have logs on both sides of the equal sign. Okay, that's important. When you have logs on both sides of the equal sign, they have the same base. Okay, that means just like when we work problems that have exponential problems with the same basis, we get to drop them. So we have same bases. So that means I can drop my logs. X squared minus 4 equals 3x. Now I have, we already know what's called a quadratic equation. So a quadratic equation, I'm going to set equal to 0. Okay, now that means I'm going to solve for x. So how many possible answers am I going to have? 2. Notice I said possible. I'll get back to that in a minute. So we're going to factor. All of these you'll be able to factor. So what two numbers multiply together? That's going to give me 4. But whenever I subtract them, I get -3. And you're right, -4 plus 1. So I said I'm both equal to 0. So x is equal to 4 and -1. Okay, here's the deal. With logarithms, you cannot have a negative answer in logarithms. And what I mean by negative answer, I mean by whatever this right here is going to be. It cannot be 0 or negative. This cannot be 0 or negative. So if I plug in 4, 4 squared is 16 minus 4 is 12. 3 times 4 is 12. So 4 checks out. Now, if I plug in -1, -1 squared is 1. 1 minus 4 is -3. So therefore, -1 is not my answer. My only answer is 4. Okay? That's it. Now, here's what I need you to pay close attention to. If I plugged in a -1 and I got a positive answer here, but a negative answer when I plugged it in here, I still cannot use that -1. Okay, so both of them have to be above 0. It cannot be 0 or below. Now, another thing, if this was a positive 1, Okay, let's say I got positive 4 and positive 1. If I plugged positive 1 in, 1 minus 4, I would still get negative 3. So 1 would not be my answer. So I'm saying that to say if you get a negative answer, just don't automatically assume, oh, well, I'm not going to use that, because you possibly could use that. Okay? All right. Let's go to my next problem. Sorry about that, guys. All right. Log base 3, x squared minus 15 equals log base 3 of 2x. Same bases, so I get to drop them. So I have x squared minus 15 equals 2x. Set up for a quadratic equation. X squared minus 2x minus 15 equals 0. I'm going to solve or factor. So x minus 5 times x plus 3 equals 0. So x equals 5 and negative 3. So I can plug in 5. 25 minus 15 is 10. 5 works. If I plug in negative 3, 9 minus 15, that's going to give me a negative answer. So x equals 5. There's my other answer. Okay? So we're going to take these a little bit at a time. Make sure that if you have x squared, you've got to check your answer. So check answers every time. Okay? If both of them don't work, then you put no solution. All right. We have an inequality. The first thing I'm going to do is I'm going to put this in exponential form. So what's my base? 3, and I'm going to keep x is greater than 3 to the 4th. Notice that I'm going to keep x over here. So x is going to be greater than 81. There's my answer, okay? I want to keep x, my answer, on the left side, because when we read inequalities, we read from left to right. X is greater than 81. All right. Now for this one, I want you to put, sorry about that, guys, a star by this problem, okay? Here, same rules apply. X is less than, 2 is my base, 4 is my exponent. So x is less than 16. So that means x can be any number that's less than 16. But we just learned up here with these problems that logarithms, that x cannot be 0 or below. So it can't be negative numbers or 0. So therefore, I have a restriction. So I have to put x is greater than 0. There's my answer. Okay? So whenever it's less than, that's giving you a red flag. You got to pay attention. Okay? Let's do one more of those. If I have log of 3 of x is less than 2. Okay? 3 is my base. Oops, sorry. X is less than, because I want to keep it, x is less than, 3 is my base, 2 is my exponent. X is less than 9. So because it's less than, I got to pay attention. X has got to be greater than 0. Here's my answers. Okay? All right, that should cover it for Chapter 8.4, solving log equations. Told you it was pretty easy, straightforward. So we have 3 different types of equations that we're working with right now. So just make sure that you practice and pay close attention to those, and I'll send you the correct answers by the end of the week. Love you guys. Miss y'all. I hope you're having a great day. Talk to you later. Praying for you daily. Bye.